Well, hello there, Logic 1. This morning we are going to be working on equations with exponents. This is a really great skill, especially after you've learned how to solve multi-step equations. This is kind of like our next step in how to make an equation more complicated. So we need to make sure that we remember how to solve a multi-step equation, how we isolate a variable by removing all of the terms on the same side of the equation that contains the variable to the other side, remembering that an equation is like a balance. So I hope that you guys did your facts practice. I hope you guys did your mental math warm-up and your problem solving. Those guys, I know it's easy to overlook those. They are really important for you to do. So let's go ahead and hop into what we are going to do today. So if you look over here, we have an equation. We have 3x squared plus 1 equals 28. Oh, that is going to be too thick. Unacceptable, unacceptable. So we have 3x squared plus 1 equals 28. So we have to remember that our job here is to, oh goodness, our job here is to identify what x is. And I don't know how to make this smaller. I'm going to pause, you guys. Hold on. All right, I kind of figured it out. Didn't want to waste your time with me talking about how to figure it out. So anyway, so our job here is to identify what this value of x is. So we're going to treat this just like we would a regular equation, because it is a regular equation. It just has a new dynamic to it. So we're going to subtract 1 from both sides. And now we are left with 3x squared is equal to 27. Well, now, again, we're going to divide by 3 because we're trying to get x all by itself. And now we have x squared is equal to 9. So now what we have here, x squared equals 9, is the same as saying x times x equals 9. When you have your perfect squares memorized, you know that 3 squared is 9, or 3 times 3 is 9. But how do we actually do that in our equation is we take the opposite of a square, which is called our square root, and we're going to root both sides. And what we get is x is equal to 3. And that is our solution. But also, a couple lessons ago, we talked about how you can have, when you are rooting a positive number, its product can also be a negative 3. We would say that 3 times 3 is 9, but also negative 3 times negative 3 is 9. So really there are two solutions to this equation, x is equal to 3 and negative 3. So let's go ahead and go to the next one. The next one is 3. Oh, goodness gracious. I'm pausing you guys again. Okay, I'm back. So here we go. So our next equation is 3x squared minus 1 is equal to 47. So we're going to follow the same steps. We're going to isolate the 3x squared, or the first term that contains a variable, by getting rid of each term that does not have a variable and combining like terms. So now we have 3x squared is equal to 48. We're not done yet because now we have to divide both sides by 3. And we get x is equal to 16, because 16 times 3 is 48. Oops, x squared, but we're not done yet because now we have an x squared and we need to have x isolated. So to undo that square, we're going to root both sides and we get x is equal to 4 and negative 4, because both 4 squared and negative 4 is equal to 16. So let's do the next example. All right, the next example is 2x squared equals 10. So here we are going to divide both sides by 2. We get x squared is equal to 10. Well, 5 is not a perfect square. So when we have the end of our equation where it's not going to be a perfect square, we're still going to root. We're still going to apply that root. So to undo that square, we're going to root on both sides. And now we have x is equal to the root of 5 and the root of negative 5. We're going to put the negative sign on the outside and the root of negative 5, and that right here. And it says right here, it says since negative 5 is an irrational number, it means it has a repeating decimal, on and on and on. We leave it in radical form. And the negative of root 5 is negative on the outside of root 5, not inside. We don't want to keep our negative side inside the root. So let's look at example 5. It says 5 less than what number squared is 20. So we're going to translate that into our equation. 5 less than, and that means that we're subtracting 5 away from some number. 5 less than what number? I think it is number squared is equal to, or is 20. So we're going to follow the same exact steps. We're going to add 5 to both sides. And now we're going to get n squared is equal to 25. This should be easy peasy because we know we're rooting this to get rid of that radical sign. N is equal to 5 and negative 5. And there you go. So let's flip the page. All right, let's go ahead and look at example 4. And this is an important one for you guys to read pretty thoroughly through and to think about. It says, in this figure, the area of the larger square, so that is this square right here. So let's look at this picture, and I drew it over here. It says, in this figure, the area of the larger square, so this larger square is 4 square units, which is twice the area of the smaller square. What is the length of each of these sides of the smaller square? So we know that the length of the larger square, or the area, is 4. So let's say 4 square units, right? We know that it is also double the area of this inside square. So we're going to use S to stand for the length of each side of the smaller square right here, because the question is asking, what is the length of the smaller square? So side squared is the area of the smaller square. So if I were to put this guy, I'm going to put S right here, S, S, and S. We know that the area of the smaller squared is going to be S squared. We also know that the length of these sides, this larger area, the area, is 4 times the side of this. So we're going to say that the larger square is 4s squared because it's 4 times, or 4 square units, the length or the area of the smaller square. So, my bad. Hold on. It was 2 times, not 4 times. 2 times, Colleen. I mean, Mrs. Bunker, to you. 2 times the square. There you go. We know that the total area is 4 square units. That's what I need to say. So now let's go ahead and solve the equation in 2 steps. We're going to divide by 2 on both sides, and we're going to get S squared is equal to 2. Well, when you root both sides, because we're trying to get rid of that square, we get S is equal to the root of 2 and then negative root 2. And that's going to be the side length of the smaller square inside the larger square. So let's do example 5. It says x over 3. So let me move this out of here. I'll move it up. So there you go. All right, so we got x over 3 is equal to 12 over x. Oh, this is great. Okay, so we're going to apply this just like we would a normal proportion. X times x, we're going to cross multiply. So we're going to get x times x, and x times x is x squared. And 12 times 3 is 36. So now we're going to root both sides because we want to get rid of that square. We get x is equal to 6 and negative 6. Okay, so guys, I want you to do your lesson practice right here. Feel free, especially for letter D. I guess there's no word problems like the square. Nope, there's not. I was gonna say if there's a problem like this example right here, please draw it out. But no, make sure that for C and D that you're writing your equations correct and that you're solving them correctly. And then of course on Thursday, we can talk about any questions you may have. Okay guys, thanks a bunch. Bye.